Welcome to the Gyroplane Flying Podcast.
Hello everyone, this is Joe Cavelli with Air Command Gyroplanes and Skywheel Rotor Blade Systems. It's a pleasure to have you join us today. This podcast is being recorded on December 7, 2020. In this podcast, I had the opportunity to interview Jim McCutchen. As many of you know, Jim is the founder of Skywheels. He owned the company from 1985 to 2001. He did a lot of blade testing in the early years, and I felt it was important to ask him some questions about that, as well as the difference between Skywheels, a fiberglass composite blade, and other types of aluminum rotor blades. Jim is a respected voice in the gyroplane community, and we have appreciated Jim's support of our efforts to reintroduce Skywheels. In March 2020, Jim toured Blackhawk Aerospace Composites, and he shared with me afterwards he felt the product was in very good hands. Before we get to the interview portion of the podcast, I wanted to let you know we are manufacturing Skywheels exactly like the original rotor blades made in the 1980s, 1990s, and 2000s. Everything is exactly the same for materials and process. We are using the original production molds and test equipment. Over 6,000 rotor blades were manufactured using this process and equipment. The rotor blades are not only time-tested, but on our website under the Skywheels tab, I share the destructive testing test data. As you probably know from following our progress, viewing videos on our Skywheels YouTube channel, or scrolling our website, the rotor blades are being manufactured by the team at Blackhawk Aerospace Composites in Kentucky. We've worked closely with their management, engineers, and production staff. When getting started about 18 months ago, I had one goal: make the rotor blades as good as the original McCutchen Skywheels. We did not look for ways to cut costs or substitute materials, but rather keep everything the same and add value where we can. Our flight testing proved we met our goal when the two pilots reported the rotor blades flew as good as the originals. They should, because we did not change anything. Those buying Skywheel blades are purchasing an engineered aviation part that has passed AS9100 aerospace quality control steps and workflow management at Blackhawk. Every part is tracked, checked, verified, and tested. In addition, we've recently purchased thousands of dollars in digital quality control equipment for blade spin-up, balance, and track to bring the process up to current technology. We'll be installing this equipment in the coming weeks. These steps speak to our commitment to quality control that you would expect. We don't manufacture the cheapest rotor blades, and that is for very good reasons. Our plan at this time is to start delivering rotor blades in January. This is subject to change because of COVID-19 and our ability to complete the remaining tasks. Skywheels has a long-standing reputation in rotor blade performance and safety. It began with Jim McCutchen, and it continues with us today. Here's the interview with Skywheels founder, Jim McCutchen. Jim, welcome to the program.
Well, thank you, Joe.
It's a real pleasure to have you with us. Jim's been instrumental in us refreshing and restarting the production of Skywheels, and definitely wanted to have Jim join us on the podcast to share his wisdom and insight of the past history of Skywheels, some of the data and information that were collected about Skywheels along their journey. They began in 1984, and also some differences with the products that are out there. Jim, let's start off with the reputation of Skywheels. I've heard so much about them, of course. We've heard from pilots and those considering gyroplanes about Skywheels and such the reputation that's out there. Can you explain a little bit more about the Skywheels reputation and how that came to be?
The reputation, it's spotless, in a word. We've been building them, well, we started building them in 85 and quit in around 2001 or so. Made 3,000 sets, never had an unhappy customer. We took great effort to test them extensively and to make them fit the niche that we were going for, and we were successful.
During your time of ownership, how many rotor blades did you manufacture?
We did probably a little bit over 3,000 sets
During that time, where did you ship those rotor blades?
all over the world.
And what did customers share with you about the Skywheel rotor blades? What were some of the comments that they shared back with you on their performance?
Everybody, without question, loved them and still does.
Why do you think Skywheels has such a strong reputation in the gyro community worldwide?
Well, Joe, we came out with a blade that was a high-quality item. We priced it in a with a cost-effective price. We paid attention to all the details, tried to ship next day shipping, and we were pretty successful at that. We addressed each and every concern with utmost diligence, and we never lied about one little thing. Those things are not in any particular order of importance, and I'm sure there's many more that I didn't mention, but those just stick in my mind.
One thing I hear a lot of people share with me that they like about the Skywheels performance is its high inertia. It's a high inertia rotor blade. To someone that's not familiar with rotor blades, what does high inertia mean, and where's the safety factor in that?
Inertia is how much effort is required to spin the blades and how much effort is required to slow the blades down. It was not a goal to make the lightest blade possible because that would defeat the inertia issue. It's just something that the customers desired, something that would maintain its RPM even in unloaded situations.
And how does that present itself as a safety feature to have a high inertia, high performance type rotor blade?
Well, if you're flying along with a 1G load on the blades and you get into a situation where there's, maybe a severe downdraft or a pilot-induced situation where there's no load on the blades, now they have nothing trying to keep them spinning at their previous RPM. You would like to have that RPM slow down. Slow down as slowly as possible so you can maintain flying.
Now, I know in order to engineer, well, first of all, research and then engineer and produce rotor blades, I'm sure there was a significant amount of testing and data along the way when you were early in the process, Jim. What type of testing and data work did you do in the early processes in starting Skywheels?
Testing involved in those rotor blades, we could speak for hours just on that, but one thing of great importance is we built this vehicle. It was a 69 Le Mans, and it had a vertical scale that measured lift and a horizontal scale that measured drag, and both of those scales met at a rotor head, which had an overhead control stick that was accessible from where the rear seat used to be in this car. We cut the roof off, and we could measure lift to about 20-pound increments and drag down to about 5-pounder increments, and we would put rotor blades on there and run it down the road in auto rotation, and I would do my best to get a failure, in addition to just getting measurements of lift versus drag. And as far as trying to get a failure, I'm talking some radical maneuvers that you could not ever attain in an auto gyro. I could get the tips right below supersonic speed, which you can't do in a gyro. Cycle the blades in the pitch mode, 4.5, huge, maybe 30 degrees of pitch travel, maybe cycling one cycle per second, just to see if we could induce, get a failure. Never did, but it was great fun.
Okay. And you call that vehicle, I know there's a name for it, you call that test vehicle?
Gyro car.
so appropriate. And the thing is, I've seen a picture of the gyro car. It was quite the test vehicle.
Oh, it was.
But it served its purpose.
It was great. I mean, what else would you call it, Joe?
So appropriate. Well, I know with anything, typically coming out with a new product or designing a product, researching a product, it usually starts with an idea. And unfortunately, sometimes, or fortunately, sometimes those ideas come out of events. How did you come out with or get the interest to do and manufacture rotor blades? Well,
that's a good one, Joe. The process of developing an ultralight helicopter kit was going to be a CG shift arrangement. And during that time, the first thing I developed was these rotor blades. I had the opportunity to check out the first time I ever saw an autogyro in person in flight. Unfortunately, the pilot had a fatal accident. I had the opportunity to look at he was flying along and either had a pilot-induced oscillation, that's what they would call it nowadays, or for some reason, his rotor blade came down and hit the vertical stabilizer and broke off at about 250 feet elevation. Of course, he died, and I had the opportunity to run up there and look at the root of the rotor blades. Right away, it occurred to me that I could do way better than that. Of course, the blade's not supposed to be able to withstand a vertical stabilizer strike, but it just sinked into my head that I could beat that. And there we go.
That you did.
Yes.
And the rest is history. Yeah, the rest is Skywheels. Well, Jim, let's talk about the difference in rotor blade types. There's a few different types that are on the market now: aluminum, extruded, and of course the composite blades, which Skywheels are. Given your experience in researching, designing, and developing rotor blades, what's your opinion on the differences between the types that are out there, with the understanding, given the amount of time and materials to make these blades, the price is different also. There's a variety of prices out there. But if we looked at it from the material and manufacturing process standpoint, how do you see the differences?
Okay, that's an easy one. In terms of quality, right below Skywheels, or at some point below them, you have the extruded aluminum spar with top and bottom skins bonded onto that spar and then bonded at the trailing edge. And the problem with that system is you can't really maintain an accurate profile of the airfoil with just unsupported aluminum skins, unless those skins are around a foam core or an aluminum honeycomb core, some sort of core that defines the profile of the airfoil. If they're just unsupported, they're going to bend to wherever they want, and which gives you a little bit of inaccuracy, so it's not a real accurate airfoil. And then it's aluminum, so you have the fatigue characteristics of aluminum, which are not near as good as composites, which is a subject that you could spend another several days on. And then below them would be the extruded aluminum blades, which I don't much care for at all. They're relatively cheap to make. Having custom dies made is not a big deal, but it's difficult to extrude a cross-section of anything that is really thick in one spot and really thin, or at least you're trying to get it really thin, in another spot. And so you're thick up by the leading edge, getting the CG balance just right, and then you're trying to make the trailing edge portions as thin as possible. And it's very difficult to do that with an extrusion because the material wants to come out of the die easily at the thick spot and is hard to get out in the thin spot. So the actual part that comes out will want to bend on you. So you end up with a heavy blade because you could only go so thin on the skin, what would be called the skins. And it's just heavier than necessary, but it's a very inexpensive way to make them.
Why do you see that as the more advantageous blade given the variety of manufacturing or types out there?
The profile is molded into the skins. They come out with the skin, with the shape that they're supposed to have. And the fatigue characteristics, a lot of people think composites don't have any fatigue, but they will fatigue over time, but that's a way greater time than aluminum. Basically it in a nutshell. The skins are molded and the fatigue characteristics are way better.
And I'm sure the time to make them, there's significant difference also.
They take longer to make them that way because you've got to mold the skins where instead of just slicing off pieces of aluminum.
Jim, what are some things that you'd like our listeners to understand that maybe we haven't covered yet regarding Skywheels?
I would think if I was just getting into the sport, I would get on the popular rotorcraft, the PRA forum, even if it requires joining it, which is not a bad thing, and talk to people that are familiar with Skywheels and familiar with the aluminum blades. Talk to some people that have been in the sport for a while. That's the best information you can get from people that have been in the sport for a while.
I have to share a couple stories with you. I've received some calls here in my short ownership of Air Command and Skywheels, and I've had a few people share stories with me that when Skywheels was sold, you had sold Skywheels to Jim Lizzie back in the early 2000s, around 2001. Immediately, they didn't know what was going to happen with Skywheels, and with that understanding, they would go out and buy a used Air Command gyroplane that had probably a 23-foot blade set on it of Skywheels, and they were buying the Skywheels and the gyro simply to get the rotor blades, and they would go on and sell the gyro without the rotor blades just to get a set of Skywheels. And Jim, I heard that story 2 and 3 times. That was the only way they were assured of getting Skywheels at the moment, because they just didn't know if they were going to come back into production, and they heard great things about it, or they wanted a second set. So they were actually buying used gyros just to get the rotor blades. So just to share a few stories that I've heard along the way about Skywheels and its reputation.
That's interesting, definitely.
Yes, and I've heard other good stories as well about the performance of Skywheels, the ease of handling, the flight characteristics, the safety factor with the inertia built up into the blade, especially as a newer pilot coming in for a landing, having that extra set of inertia behind you if you accidentally raise the nose too high and you bleed the lift. And just to let our listeners know, Jim will be assisting and participating with us in other ways too, and offering technical assistance and guidance to people that have questions for us. So Jim, thank you very much for your continued involvement with Skywheels. It's great to know we have your participation in this, in bringing back Skywheels to the market as the founder and inventor, and I know everyone will find benefit in the message you have to share. So thank you very much for being with us today, and we look forward to having you back again on future podcasts.
I love it, Joe. You're welcome.